With these couple slides, I would like to talk about uh, economy of movement and efficiency of movement. To start off with, we'll look at economy, and economy will use the aerobic power, or not the maximal aerobic power typically, but um, oxygen consumption or aerobic power at a given running speed. And certainly VO2 max, maximal aerobic power, and also the efficiency of using that energy and the economy of movement can really affect endurance performance. So is there a difference in the economy or efficiency of these athletes and these different athletic events? Very interesting question. And to measure run economy or efficiency, we need to measure the oxygen consumption either in a laboratory setting or using a portable VO2 analyzer. So the economy of movement reflects the relationship between energy input and output. So at a given submax speed of running or cycling or swimming, the person with the greater movement economy or better movement economy will be consuming less oxygen at that given speed. So the measurement of the oxygen cost of running at various speeds, this oxygen cost of running, if someone is more economical, that means, or a greater running economy, that's reflected by a lower oxygen cost. So higher economy or better economy means that there's less energy expended at that given running speed. So for running economy, and we usually use the term economy, because it's hard to measure efficiency on the treadmill because there's no external work being done. You're actually running in place. Therefore, economy is the term that is used and is reported, or typically reported, as the amount of oxygen consumed per body mass per kilometer of distance traveled. And I'll show you a conversion. So running economy is a measure of how efficiently someone is using oxygen while they're running at a given pace. And again, it's the rate of oxygen consumption per distance covered. So it's milliliters of oxygen per kilogram body weight per kilometer traveled. Running economy is the energy required to run submaximally at a given speed or given velocity. And so here's a graph of oxygen uptake on the y-axis and running speed on the x-axis. And there's two lines on here. And as speed goes up, the oxygen consumption goes up. And we could ask who would perform better, runner B or runner A. And if we would pick a given submaximal speed, let's say 200 meters per minute, runner B is consuming less oxygen than runner A at that given speed. So if this is a long distance event, we would like to be more economical. We'd like to be going at a certain speed, 200 meters per minute, and consuming less oxygen. That means we're more economical. So runner B in this case would be performing better. And some typical running economy values, I always remember or think of the number 200, and that's 200 milliliters of oxygen per kilogram body weight per kilometer traveled. Or mils of oxygen per minute. This should be per km actually. So ACSM has a reference value of 218. Here's some good runners elite Europeans, North Americans, elite East Africans. So they're below that value of 200. So typical values of mils per kg per kilometer traveled. And several years ago, we've tested the SUNY Cortland women's cross-country team, and they were pretty good. So they were under 200. So either at 90% of their VO2 max on the left-hand side or at 80% of their VO2 max on the right-hand side. They were at 197 or 195 mils of oxygen per kilogram body weight per kilometer traveled. And so here's an example of the calculation. So if someone's running at 8.4 miles per hour, convert that into meters per minute, so multiply by 26. So that speed is 225.2 meters per minute, or convert that into kilometers per minute, it's 0.2252 kilometers per minute. Their oxygen cost at 8.4 miles per hour was 41.9 mils per kg per minute. So 41.9 divided by this speed of 0.2252, that's 186 milliliters of oxygen per kilogram body weight per kilometer traveled. And so that would be a good run economy measure. So that was an example of run economy. In the next short video, I'll look at muscular efficiency.